Greenland is also thought to be kind of a canary in a coal mine. A lot of scientists believe that climate change will first show up at the polar regions. Greenland acts as sort of a climate buffer. If you have a glass of water and you have a cube of ice in that glass of water, that glass, the entire glass of water, will stay at 32 degrees until the ice melts. As soon as the ice melts, the temperature, if the ambient temperature is above freezing, the temperature of all that water will go up. And Greenland acts in a more complex way in that same buffering mechanism with the Earth. If Greenland, because of its presence, and Antarctica, all the ice masses together act as a buffer on climate. And so, if they were to start to melt, which many people believe that they are, then the eventual effect will be a warmer climate overall.
But Elvis is a high altitude instrument. We want to fly as high as the plane can fly. So then that gives us this widest swath of data. So the DCA can fly quite high. It can fly 40,000 feet for 10 or 12 hours. It's quite a long endurance and range. So Elvis provides very accurate data also. Maybe 10 centimeter accuracy, maybe a little bit better. And we can do that across the whole swath from high altitude. So that allows you to pick the application. So if you want to monitor very precisely how the ice sheet is changing, then we can use Elvis to do that. If you want to look at areas that are very dynamic, like a glacial region, that's actually a lot of ice is moving through and there's a lot of vertical changes, we can map that entire area and capture the full spatial variability of that change, which is really a good indication of what's the mechanics of how that change is happening.
NASA's Operation IceBridge mission, the largest airborne survey of Earth's polar ice ever flown, kicks off its second year with the arrival of 2 NASA aircraft next week in Greenland. The team will spend 200 hours in the air gathering data using a suite of instruments that peer below some of the region's critical glaciers. IceBridge is aptly named as it will bridge the data gap between the loss of NASA's Ice, Cloud, and Land Elevation Satellite, or ICESat, and the launch of ICESat-2 planned for 2015.
I think it's probably safe to say that if it weren't for Operation IceBridge or similar efforts, that the global science community would lose a lot of its knowledge about what's going on with Greenland and Antarctica as a whole.
200 hours in the air require a lot of work on the ground. Engineers have been outfitting NASA's DC-8 and P-3B aircraft with an array of science instruments. IceBridge planes will resurvey previous ICESat tracks to get a sense of how Arctic ice is changing.
I think the last thing that NASA would like to see is to take a snapshot of the ice at the end of the ICESat-1 operational period, get another snapshot at the beginning of ICESat-2, and have no idea what happened in between. And that's essentially what IceBridge is about, is filling in that gap of knowledge.
If you want to look at areas that are very dynamic, like a glacial region, that's actually a lot of ice is moving through and there's a lot of vertical changes, we can map that entire area and capture the full spatial variability of that change, which is really a good indication of what's the mechanics of how that change is happening.
Greenland, because of its presence, and Antarctica, all the ice masses together act as a buffer on climate. And so if they were to start to melt, which many people believe that they are, then the eventual effect will be a warmer climate overall.
Annual spring missions over the Arctic and fall missions over Antarctica will allow scientists to track changes in polar ice thickness and extent, so we have a better picture of ice dynamics and future sea level rise.